Hello, today's lesson is all about factors. We're going to understand what factors are and find the factors of a number. We're going to understand prime numbers and composite numbers, and we'll be looking at prime factorizations and how to do this. Factors are numbers that we multiply to each other or to other numbers to give a product. So in this example, 2 times 2 is equal to 4. So 2 is a factor, 2 is a factor, and 4 is the product. And if we look at the number 4 as a product, what makes 4? Well, 1 times 4 makes 4, and 2 times 2 makes 4. So therefore, the numbers 1, 2, and 4 are the factors of 4. The number 1 is a factor of all numbers because of the property or rule of 1. And that property of 1 states that any number multiplied by 1, so let's say 12 times 1, is just going to be the same number. And the same goes with division. The 1 property tells us that if we divide a number by 1, we're just going to end up with the same number. So we're going to begin with the number 1 when we're listing factors. So we have the number 30 and we're asking ourselves what makes 30. The best way to go about this is to start with the number 1 and work systematically. So 1 times 30 makes 30. And now we go to our next smallest number, which is 2. 2 makes 30, 2 times 15 makes 30. Then we ask ourselves about a 3, and yes, 3 times 10 makes 30. Then we ask about a 4. Nope, 4 does not make 30. 4 times 7 is 28. Then we go to 5. Yes, 5 times 6 makes 30. And notice that 6 is over here. We can ask ourselves about 7, 8, 9, and then hit 10. As soon as we're on this right-hand side, we know that we've got all the factors. So what we can do is list these factors using a U-shaped method where we're going to be going in order, listing all the factors of 30. 1, 2, 3, 5, 6, 10, 15, and 30 are all the factors of the number 30. So for the do together, we're going to find all the factors of the number, and we're going to start with the number 1. We're going to start with the smallest number. 36 has quite a few factors, so we're going to start with 1 times 36. Then we go to 2. 2 times 18. So sometimes it takes a little bit of scratch work on the side to figure out what all the factors are. 3 makes 36, 3 times 12. 4 makes 36, 4 times 9. But 5 does not make 36, but 6 does, 6 times 6. 7 does not, 8 does not. The 6 is over here, so we know that we're finished. So these are all our factors of 36. 1, 2, 3, 4, 6, 9, 12, 18, and 36. 120 has a lot of factors. So we go one step at a time. 1 times 120. 2 times 60. 3 times 40. 4 times 30. 5 times 24, 6 times 20, 8, there's no 7, 8 times 15, and 10 times 12. That's a lot of factors for 120. If we wanted to write them in order in a list format, we'd say 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120 are all factors of 120. So why are we doing all this factor stuff? Well, really what we're working towards is being able to reduce fractions, and the way we can do that is by understanding the greatest common factor. So what we're looking for is the largest number that makes two numbers, for example, 18 and 24. So the GCF, or greatest common factor, is the biggest number that makes both of these numbers. So in order to determine that, we're going to have to write all the factors. So 1 times 18, 2 times 9, 3 times 6. all of these are factors of 18. For 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And then we look in our lists and we find the numbers that match, but the biggest one is the one we want. And when we look at 18 and 24, the largest common factor that they share is the number 6. So the GCF, or greatest common factor, of 18 and 24 is 6. So we're going to find all the factors and circle the greatest common factor. So 12 and 8. For 12, we can do 1 times 12, 2 times 6, 3 times 4. For 8, 1 times 8, 2 times 4. That's it. So we can see here that the greatest common factor is 4. So we write GCF equals 4. For number 2, we have 25 and 20. We start with the number 1. 1 times 25. 2 is a no, 3 is a no, 4 is a no, 5. 5 times 5. That's it for 25. For 20, 1 times 20, 2 times 10, and 4 times 5. And we can see that the greatest common factor for 25 and 20 is 5. Now let's look at products of prime factors. Prime numbers are numbers that have only 2 factors, the number 1 and itself. So if you look at the word prime, you can make a little memory tool by changing the I to a number 1 and seeing the word me. Prime numbers only have 1 and me, 1 in itself. The number 2 is your smallest prime number, and it's also the only even prime number. So the rest of the prime numbers are odd, but don't be fooled that all odd numbers are prime numbers. Some of them are prime and some of them are not. Okay? So numbers like 17, 23, 41, these are prime numbers. The only factors are the number 1 and itself. The opposite of prime numbers are composite numbers. Composite numbers have more than 2 factors. So these are the numbers that are typically even, but we have quite a few odd ones too. So 4, 6, 8, 9. If you look at 9, it's an odd number, but we have 3 times 3, and of course 1 times 9. Same thing goes with a number like 15. 15 has 1 times 15, but also 3 times 5. So 9 and 15 are examples of composite numbers that are odd. Remember, the number 2 is a prime number. It's the only even prime number. The rest of the even numbers are composite. So let's take a look at writing numbers as a product of prime factors. We have a division method and a factor tree method, and they're very, very similar. So I'm going to show the division method, although I prefer to use the factor tree method. So with the division method, we're dividing by the lowest prime number and continuing until we end with 1. So the lowest prime number is 2, the next lowest is 3, and the next lowest is 5. We're going to divide 24 divided by 2, which equals 12, and then 12 divided by 2, which equals 6, and then 6 divided by 2, which equals 3. And then from there, we're no longer able to divide by 2, but we can go to the next prime number. 3 divided by 3 equals 1. And then what we see here is we divided by these prime numbers. So 24 is the result of 2 times 2 times 2 times 3, because these were the numbers that we divided by. The factor tree method can be done in a couple of ways. I prefer the first method, which is kind of similar to the division method, where we take the number 24 And again, we start with our smallest prime numbers, 2, 3, and 5. So I begin by trying to divide by 2, which gives me 12. Now I divide 12 by 2, which gives me 6. Divide 6 by 2, which gives me 3. And 3 is my last prime number, so I circle, 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 and circle, and these are my prime factors. 2 times 2 times 2 times 3 equals 24. Or I can express this using exponents. 2 times 2 times 2 is the same as 2 to the power of 3 times 3 is equal to 24. Some people do the prime factorization differently. So for example, they take any numbers that make 24. In this example, they did 4 times 6, or you could take 3 times 8, and then from there break it down to prime numbers. 2 times 4, for example, and then 2 times 2. You're still going to get the same answer, but what I don't like about this method is sometimes it can get confusing with big numbers, and the different factors can get mixed up in terms of order. I find if you go with your smallest numbers, you'll end up getting the order you want, and you can read the numbers looking down and across, whereas here you're going to have to look up. So it just does depend, and then you can see this one, all of the factors are written across. So it does look different, but it works just as well. So for this do together, we're going to use factorization using the factor tree method. So starting with our smallest prime numbers, we're going to try for a 2, a 3, or a 5, and then if we can't do that, we'll go up to 7 and so on. When we look at the number 75, this number is not divisible by 2, but it is divisible by 3. So we go to our next prime number. 75 divided by 3 is 25. Now we're at 25, we have to divide that one. It's not divisible by 2 or 3, but we can divide it by 5. And we end up with the answer of 5. And 5 is a prime number, so we're done. So 3 times 5 times 5. So 75 is 3 times 5 times 5, or we can write it as 75 is equal to 3 times 5 squared. And I like to write it with exponents, so you have to be prepared for both methods. For your answer, either one is perfect though. For number 2, if we're looking at 36, I'm going to use my smallest prime number. So I'm going to divide by 2, which gives an answer of 18. Divide by 2 again, which gives an answer of 9. Now I can't divide by 2, but I can divide by 3. So 9 divided by 3 equals 3. And now I'm finished. So 2 times 2 times 3 times 3. 36 is the result of 2 times 2 times 3 times 3. Or we can express it with exponents. 36 is the result of 2 squared times 3 squared. It's important to note that you can do this differently. 36 you could do 6 times 6, and then break down 6 divided by 2 is 3. 6 divided by 2 is 3. You will still end up with the same answer, but if you want to express it correctly, you will have to write it the way that we have written it. 2 times 2 times 3 times 3. You should put the factors in numerical order, or you can use exponents. So for exercise 3.4, you'll go ahead and find the greatest common factors, or GCF, and you'll also use prime factorization, and I recommend this factor tree method.